Alright, I'm Caleb Stombaugh, and I'm doing a differential equation problem with Laplace transforms. First, we are given the problem x double prime minus 4x equals 3t, and our initial conditions are that x of 0 equals 0 and x prime of 0 is also equal to 0. And to start off the problem, we need to take the Laplace of both sides. But before we do that, we know that the Laplace of x double prime is equal to s squared, the Laplace of x, minus s times x of 0 minus x prime of 0. And that the Laplace of x is just equal to the Laplace of x. Alright, knowing that, we can now take the Laplace of all of this right here, and which is both sides of the original equation. And so the Laplace of x double prime, I said it earlier, s squared Laplace of x minus s times x of 0 minus x prime of 0, and then minus 4 times the Laplace of x, which is this second term right here. And then you also take the Laplace of the right hand side, which is just the Laplace of t. I pulled out the 3 right here, and we know that the Laplace of t is 1 factorial over s squared, and so I already evaluated that here on the right side, and I put the 3 back in there in the numerator, so it is 3 over s squared on the right side, and that side is done with the Laplace for now. And now we can use our initial conditions. So we know that x of 0 is 0 and x prime of 0 is 0. And so there we can plug those in right here and here. This is where they apply. And s squared L of x, or Laplace of x, doesn't have any initial condition, but these two do, and they just become 0 because it's 0 times that term. So now we're left with simplified this equation right here. S squared Laplace of x minus 4 Laplace of x equals 3 over s squared. And now what we want to do is solve for L of x, or Laplace of x, and so I factored out this s squared minus 4, which are the two terms with Laplace of x, and then we'll divide by s squared minus 4 on both sides to get L of x by itself. And so we have this term right here. And now looking at it, I can tell that I'm going to have to do partial fractions, and so after I spread it out partial fractions wise into 3 terms, because s squared minus 4 is equal to s minus 2, s plus 2. And so here is where I'm doing partial fractions, and so it's going to be that 3 over the 3 terms, 3 over s squared, s minus 2, s plus 2 equals a over s minus 2 plus bs plus c over s squared. Because it's squared, we have to have 2 terms in the top, plus d over s plus 2. And here I'm evaluating that, which I get the 3 on the top up here, equal to all these terms when we multiply by the other denominators that aren't under the same one. And therefore I get the series of equations, and from these it's pretty easy to solve for the 4 letters. A, I found, was 3 over 16, B was 0, C was negative 3 over 4, and D was negative 3 over 16. And so now I take these values and I plug them in to what was up here, and I get this L of x equal to these 3 fractions. And I notice also that I can combine these two right here, and I get one fraction, which is right this one, this 3 over 4 s squared minus 4. And so it's just 2, and I know how to get the Laplace, inverse Laplace of both of these, which is what we're going to do next. That's what you want to do right from getting these fractions to the next step. You want to get them in a form where you know how to get the inverse Laplace transform of them. So now we need to take the inverse Laplace, like I just said, and so our new equation that we're looking for is in terms of t. So I've pulled out these constants, negative 3 over 4, and then just had the inverse Laplace of 1 over s squared, plus I pulled out the constant again, 3 over 4. to have the inverse Laplace of the second term, 1 over s squared minus 4. And so in the second term, I need a 2 in the numerator though, because this is our a, and I need it in the form a over s squared minus a squared. And so I know our a is 2, so I put that 2 in the numerator, but I also have to multiply by 2 in the denominator on the outside to even it out, just so you're multiplying by 1 and not changing the equation. And so now that I've done that, I can take the inverse Laplace of both these terms, and the inverse Laplace of 1 over s squared is equal to t, and the inverse Laplace of 2 over s squared minus 4 is equal to the hyperbolic sine of 2t. And so, once I plug those in and use these numbers that I've pulled out, I get this final answer. The f of t, our function, is equal to negative 3/4 t plus 3/8 hyperbolic sine of 2t. And that is how I solved this problem using the Laplace transforms. By quick overview, using the substitutions that we know and taking the Laplace of both sides, using partial fractions, and then finally using the inverse Laplace to find our final answer, which was this right here. Alright, thank you very much.